So we're going to go over the exterior angle theorem. But first we need to know some things with an exterior angle. First, the green triangle here that I've drew on the right, an exterior angle is when you take one side of the triangle and extend it. So if I extend this side of the triangle, right here is my exterior angle. And then the remote interior angles are what we also need to identify. And from this exterior angle that we've created, the remote interior angles are opposite, but inside, because it's remote interior angles, opposite but inside of this triangle. So let's look at our exterior angles in this example. So if I have extended this side of the triangle, the exterior angle given is angle 1. Angle 2 is not an exterior angle in this case, because this angle is made when you extend two sides of the triangle. You have to extend the side we just extended and this other side to create angle 2, which angle 2 and angle 4 are vertical angles, also not making it an exterior angle. If we extend this side of the triangle, we have then created angle 3, and then extending the top gives us angle 8, and then extending the bottom this way gives us angle 9. So now we want to identify the remote 2 interior angles of each of these. So angle 1 is right here. Remote 2 interior angles are the opposite 2 angles inside the triangle. Remember, a triangle only has 3 angles. The opposite 2 that are inside the triangle are the remote interior. So angle 1 and angle 5, oh, not angle 1, angle 5 and angle 6 are remote interior to angle 1. From 3, the opposite 2 inside are also angle 5 and angle 6. And if you look, 1 and 3 are vertical angles because they are opposite sides of each other. So those are going to be equal in measure. They're going to be congruent. So down here at the bottom, angle 1 is going to be congruent to angle 3. They're vertical angles, and check this out, they have the exact same remote 2 interior angles. Now angle 8 is up at top. The opposite 2 interior angles of angle 8 is angle 4 and angle 6. And then if we look at angle 9 here, the opposite 2 interior angles of angle 9 is angle 4 and angle 5. And 1 and 3 are the only 2 exterior angles that are going to be congruent that we know of in this example. Angle 4 and 2 are also congruent, but again, 2 is not an exterior angle, and 7 is not an exterior angle up here. That's just a straight line. That's 180 degrees. All right, so which are the 2 remote interior angles to angle 6? Well, here's angle 6, and we want the opposite 2 interior angles of the triangle. Here's our big triangle. Opposite of angle 6 that are inside the triangle is going to be angle 1 and angle 5. So angle 1 and angle 5 are remote interior angles. Now, the reason why we're harping on these remote interior angles and an exterior angle is we're going to want to find the measurement of these exterior angles. So, just like we did in the previous lesson, we can replace this missing angle with x. Now, an exterior angle, see how the exterior angle is made here by extending this side? The exterior angle is always equal to the sum of the remote interior angles. That's why we needed to identify the remote interior angles, the opposite 2 angles inside the triangle. So here, to find our exterior angle, we need to add the opposite 2 interior angles. And when we do 34 plus 90, we get x equals 124. And that's how big that angle is. This next example, 71 is my exterior angle. The exterior angle always equals the sum of the 2 remote interior angles. So I'll go ahead and call that x. We can call that anything we want. Plus 43. Now this becomes an equation that we've been dealing with all year. So now we need to solve this equation. It's a one-step equation where we subtract 43 from each side, and we get x equals 28. So that angle is 28 degrees. All right, so I'm going to call the outside angle B, just to mix it up a little bit. That is my exterior angle. That equals the sum of the remote to interior angles. And then when I do 53 plus 61, I get my exterior angle to equal 114. Again, I have this box here. We should know what this box means. That is a 90-degree angle. There's my exterior angle because that's on the outside of the triangle made when we extend one side of our triangle. And that equals the sum of the two interior angles. Now I just need to one-step equation, just subtract 73 from each side to isolate my variable. X equals 17, so that angle is 17 degrees. Here we go again. My exterior angle is 132. That equals the sum of the two remote interior angles. One step here, subtract 28 from each side. X equals 104. All right, now we have to substitute some things in here. So I only have three angles listed. Angle 3, which is my exterior, equals angle 2 plus angle 1. We can say the measurement of angle 3 equals the measurement of angle 2 plus the measurement of angle 1. Well, here the measurement of angle 3 is 5x minus 8. So instead of the measurement of angle 3, I'm going to put 5x minus 8 equals, and then I'm going to substitute what the measurement of angle 2 equals, plus what the measurement of angle 1 equals, and now I can solve for x. So I have like terms on the right. 5x minus 8 equals 3x plus 24. I'm going to move all of my variables to one side of my equation. And I'm going to eliminate all constants that are on the same side as my variable. Equals 32 divided by 2. X equals 16. So I found my x value, but I did not yet answer the question. The question says, what is the measurement of angle 3? Well, here is angle 3, 5x minus 8. I now know what x is, because x is 16. So I need to substitute 16 in for x. 5x minus 8. So this is 80 minus 8, which angle 3 measures 72 degrees. All right, same thing here, only now I have a box, which tells me that's 90 degrees. So the measurement of angle 1 is my exterior angle. That equals 90 plus the measurement of angle 2. Substitute these values into my equation that I have set up. So again, it says the measurement of angle 1 is 5x minus 18. 1 is my exterior angle, so I substitute 5x minus 7 or 5x minus 18 in to there, and then angle 2 I substitute 3x minus 40, and now I solve. I have like terms, so 5x minus 18 equals 3x plus 50. Again, we want to eliminate all our variables from one side of the equation. So now that I have all my variables on one side, I need to move or get rid of all my constants that are on the same side of my variable. And I have found my value of x. Now again, that is not what the question asked, but in order to answer this question, we need to solve for x. Because now I need to substitute 34 in for x. 5 times 34 minus 18. This gives me 170 minus 18 equals 152. So angle 1 is 152 degrees.